Hello everyone, welcome back to the channel Future Force. I want to take you on a comprehensive journey through one of the most dramatic and controversial episodes in recent history. The Crimean Bridge burning will examine the facts, footage, fallout, and more. We'll explore the exterior, interior, performance, safety features, unique selling points, price, and then wrap up with a thoughtful conclusion. Let's begin by laying out the factual background. The Crimean Bridge, also known as the Kerch Strait Bridge, links mainland Russia and Crimea across the Kerch Strait and stands as a monumental feat of engineering. Spanning nearly 19 kilometers, combining both roadway and railway, it emerged in the late 2010s as both a logistical marvel and a potent geopolitical symbol. On that fateful day, an explosion ripped through a section of the bridge, igniting a fierce fire that tore across lanes and train tracks, sending thick smoke skyward and putting the superstructure to the test. Emergency teams raced to respond, media lenses captured the chaos in real time, and the world watched as speculation and controversy swirled around the cause, whether it was accident, sabotage, or an act of war. Even now, investigations remain open, conflicting claims persist, and the bridge's doused flames still echo in political discourse. This is the context for everything we're unpacking today, a foundation to understand not just what happened, but how, why, and what it means. When we turn our eyes to the exterior, the scene is both beautiful and brutal. The bridge itself is colossal, its slender spans stretching over the waters below, supported by armies of concrete piers, each a gray sentinel rising from the strait. On peaceful days, sunlight plays off its steel, the structure appears serene, resolute. But on that dark morning, the exterior transformation was shocking. Plumes of black, acrid smoke curled into the sky, tongues of orange and yellow flame licked the road surface, the girders beneath twisted and deformed, sagging under heat. Scorched asphalt revealed dark crater-like patches. Chunks of concrete and metal littered the deck and floated in the turbulent water beneath. Drone footage captured glinting shards of twisted steel jutting skyward, broken cables dangling like silent witnesses. Guardrails were bent, overhead lighting frames melted. Girders were blackened, discolored, and misshapen. That external image became a global symbol of damage and instability, an icon marred. Broken textures and glowing embers spoke to us of tremendous force unleashed. The juxtaposition of a purpose-built symbol of connectivity and the devastation unraveling across it made the exterior visuals inescapable, unforgettable, and emotionally potent. But to fully understand this event, we need to go deeper into the interior. And here is where the script of the script must breathe, because there is so much that lies beneath the surface, literally and figuratively. So let's take our time there. Inside, the bridge's inner architecture is a complex steel, concrete skeleton, trusses crisscrossing, beams forging lattice patterns, channels containing utilities, conduits for sensors, cables, data lines. Hidden within are tension rods that bear weight and control movement, maintenance tunnels where workers inspect structure, ductwork for lighting power, sensors that record vibration, camera feeds, temperature changes, strain gauges that register stress. In an emergency scenario, this interior is a nervous system that must transmit information quickly, hold weight steadfastly, and give human operators enough time and insight to respond. When the explosion occurred, that interior immediately became hostile. Shockwaves spread through the metal, steel trusses rattled, joined connections strained, welds split. The heat inside surged, temperatures soared, wires melted, conduit shelves buckled, sensors registered temperatures they weren't calibrated for. Maintenance corridors, usually safe passage for inspectors, filled with thick black smoke, making navigation deadly. Firefighters reported passages layered in particulate-laden air, sensors offline, emergency lighting flickering and failing. The infrastructure that stabilized the bridge weakened from within, sensors unable to report, cables obscured or burned, critical data pipelines lost. The ravaged interior became a shadow realm, opaque, dangerous, unknown, even as the bridge exterior stood like an embattled sentinel. What's more, inside this physical interior lies another, the psychological and strategic interior. For the engineers, security officials, and government decision makers, the bridge infarcted its way into inner calculations. How was the explosion caused? How vulnerable were key transport arteries? Did existing protocols detect threats before they happened? Were maintenance and emergency procedures sufficient? What was the fallback if the main artery collapsed? For communities dependent on the connection, anxiety gripped homes, supply lines, businesses. And for planners in the corridors of power, internal meetings churned with recalibration, alternative routes, logistical redundancy, military security, insurance claims, political fallout. That interior, that combination of hidden physical detail and private strategic recalibration, deserves deeper exploration than even what appears on camera. It shines a light on where disaster is felt most, not just on beams or roadways, but in nerves, in anxiety, in back-room meetings, and in every decision moment. Once we grasp the interior realms, we can appreciate how performance was tested. Under normal operations, the bridge moved thousands of vehicles daily. Cars, trucks, freight trains, even emergency convoys. Traffic schedules were met. Sensors flagged minor issues. Travel time plummeted between the peninsula and the mainland. Economies surged, yet at the instant of explosion, performance dropped to zero. Lanes closed without warning, rail traffic halted abruptly, alarms triggered. Inspections were scrambled. Engineers deployed ultrasound flares for stress tests. Weights were redistributed. Concrete cores were sampled. Girders were prodded with sensors for microfractures. Initial results forced closure. No public traffic resumed until safety certifications were signed off. Days later for partial openings, weeks for full operations. During that period, the bridge's performance envelope had shifted from robust throughput to emergency inspection mode. Trucks carrying food or medicine were rerouted via sea or alternate land crossings, delayed, taxed, expensive. As repairs progressed, performance trickled back, but never fully restored quickly. Speeds limited, traffic volumes reduced, train timetables staggered. That slow reinstatement became a performance metric in itself. How fast could the artery be revived? How closely could teams restore prior levels of capacity? And how effectively could engineers detect hidden damage behind the scenes? In each of these moments, we see infrastructure performance defined by extremes, from smooth efficiency to near-total collapse, and then cautious return. Moving on to safety features, the bridge embodied protective measures intended to prevent exactly such collapse, but in practice, it revealed areas of weakness. Fire sensors dotted the structure, programmed to detect smoke, high heat. Automated alerts linked to on-site monitoring centers, hydrant systems, high-capacity sprinklers, emergency phones, lighting, evacuation walkways, guardrails, all designed to rescue people and deter collapse. Sensors were redundantly powered, fireproof housings protected electronic devices, strategic structural redundancies attempted to prevent total failure if a single span failed. But when the explosion struck, several of these systems struggled. Smoke overwhelmed fire sensors before alerts could escalate. Hydrants lost pressure due to heat damage to supply mains. Fallback pumps had to be routed from land. Emergency walkways were too narrow for firefighters in bulky gear. Lights were ruined by broken wiring. Some sensors faced total power loss when circuits melted. Investigators recommended upgrades: remote fire pumps, hyper-pressurized hydrant lines, hardened enclosures for electronics, redundant power feeds, wider evacuation corridors, automated fire suppression with foam, a combination of tactical and structural improvements. We learn that safety systems are only as good as their durability under pressure. In crises, redundancy and robustness are the real saviors, not just design alone. When it came to unique selling points, this bridge had them in spades, before and after the incident, albeit in different contexts. Originally, its scale was staggering, the longest bridge connecting a region under contested sovereignty, dual-purpose roadway and railway in one, a visible symbol of engineering achievement, economic lifeline, trading, tourism, transport, aesthetic allure, light posts lining lanes, arcs of support, views over azure water, pride for governments and communities alike. Post-incident, its unique selling points transformed. It became a case study in emergency engineering and resilience. How quickly can a broken artery be assessed, secured, repaired? It is now a cautionary emblem of vulnerability. What happens when critical infrastructure is attacked or fails? It is a geopolitical signal, a line in water marking contested territory. It is now a human story, engineers working around the clock, diversion of lives, resolve amid ash. The bridge's identity shifted, from icon of nation, building to microcosm of conflict, recovery, risk management. Both viewpoints remain compelling, depending on your lens. Now we enter the domain of price, not just ticket cost of course, but the multi-layered price paid in money, time, trust, and geopolitics. To build the bridge cost billions, rubles or dollars to design, pour marine foundation, erect spans, install systems, and promise longevity across decades. Maintenance budgets carved out, renovation plans budgeted, the burning incident added millions more, emergency funds for repairs, overtime pay for construction crews, shipment of materials, replacement sensors, steel girders, cameras. There were economic opportunity costs, halted freight movement, delayed tourists, businesses impacted, supply chains disrupted, bread, fuel, medicine all delayed, per diem losses climbed steadily, insurance payouts if covered spiked. Then, the reputational price, the political face of the bridge became fragile. International investors questioned trust in mega projects, donors questioned backing, political opponents exploited any failure. The bridge is no longer just a built asset, it's a charged flashpoint in optics and finance. That price isn't a number on a sheet, it's a ledger of damage in dollars, days, and dignity. Bringing all of this together, we conclude with reflection. We've watched the exterior, in flames, marred, fractured. We descended into the interior, physical decay, strategic shock, hidden danger. We tracked performance, smooth efficiency ruptured, then recovered cautiously. We tested safety, planned protections compromised, then reevaluated. We observed unique selling point strands, formed from connectivity to resilience and warning. We calculated price, not just in cost to repair, but in trust, logistics, political impact. The Crimean Bridge burning is no mere headline. It is a living case study in how infrastructure fails, how it is defended, how it falls, and how it is rebuilt emotionally, financially, and physically. A single incident reveals network weaknesses, human vulnerabilities, economic disruptions, and the power of symbol. It forces us to reckon with how dependent we are on engineered connections, how precariously we balance them, and what we must do to prevent calamity, or recover when it strikes. In the end, the bridge stands again, a charred but intact corridor, repaired but watched, rebuilt but not forgotten. It reminds us that every road we walk or drive on passes over more than concrete and steel. It spans our planning, our security, our belief in progress. And when it burns, the cost is far more than asphalt. It is loss of confidence, security, and sometimes even peace. Thank you for watching and diving deep with me through facts, footage, and fallout. I hope this extended script gives your audience clarity, insight, and perhaps a moment of pause to reconsider the fragile links we build and rely on. Stay curious, stay informed, and I'll see you next time.